In this problem, we're going to use Mathematica to solve a linear system of equations. So here we're presented with three equations with three unknowns, x, y, and z, and it's already written in a standard form with x first, then y, then z, and on the right-hand side our constant, although for Mathematica it's not going to actually need it in a standard form. And we're going to use Mathematica to solve for our three unknowns. Since we have three variables and we have three equations, we possibly have a unique solution to this. We could check that by doing a matrix form of this and seeing if the matrix has a determinant of 0. But we're going to solve this one in Mathematica and let it tell us if we have that unique solution, or we could in theory have infinite number of solutions as well. Now we could solve this one by hand using substitution or elimination. We could also use MATLAB to solve this. If we put it into the matrix form, we could invert matrices like we do in any other linear algebra problem. But we're going to see that Mathematica is able to handle the equations directly and give us solutions and in different forms. So first, we want to enter our equations into Mathematica and then give it the command to solve our equations. I'm going to put this inside of a solve command. So I'm putting solve. Notice that solve is capitalized. All of the built-in functions in Mathematica are capitalized. So I usually reserve lowercase variables or functions for things that I'm creating. So capital S solve. And then the first thing we're going to do is put in the list of equations we want it to solve. So it's solve and then this square bracket for the solve function to begin. So I need to put in a list of equations to use. So I'm going to add this open curly brace, and this is where I begin my list of equations. And I can type them right in from what we're given. So x plus 2y plus 5z. So notice here in Mathematica, it unlike MATLAB understands that 2y, I just put 2 and then y, it understands that is going to be a multiplication. So I could put 2 asterisk y like I would in MATLAB, that's fine. I can put 2 space y. It understands it to imply multiplication. But all of those would work. A space or an asterisk, it would also understand. And now I need the right-hand side. So I'm going to use a double equals sign when I'm entering equations. A single equal sign is for allocation. So like x equals 5 is going to store the number 5 into the variable x. But the double equals says, oh, this is an equation that you're entering. And then my right-hand side of 4. So now I have the first equation entered. So now I need to put in the next ones. So I'll put a comma because this is going to be a list of equations. And Mathematica handles lists inside of these curly braces. I put here enter on the keyboard. Enter is going to start a new line, which really this is more for the visuals. I could just write it here, which I'll show right now, and just make this list all in a row. So I put in the second equation here. But for aesthetics, I'm going to put that on another line and then put a comma so I can put in the third equation. So negative 3x plus 7y plus 8z equals, double equals, 14. Right, then a curly brace to end that list. Now, the next thing I can enter in solve is the variables I want it to solve for. In this case, this is actually optional, but I will put them here just explicitly to show what's happening. So notice that the color changed. Let me get rid of the z. So the z is a dark blue in my list of equations, and when I enter it here, it becomes this like teal color. So this means that I have no dark blues left. It's going to solve for a number for each of these variables, and that's also a list. So a curly brace, x, y, z, curly brace. In a case like this where I have three equations, three unknowns, I could actually leave this list out and it's going to assume I want to solve for the three unknowns in the three equations. But putting this list here explicitly tells it, hey, solve for these things on the left-hand side. And in this case, it's going to turn out that they will all be numbers. And then I ended it with this closed square bracket to end the solve. Okay, so now I have all my equations entered in. I can make this larger. Now I can run this and actually solve for my unknowns. Now I can run it with a shift enter or the enter button on the keypad. Both of those will actually run this cell. So I ran it, and this is what it gives me. So notice it gives me this curly brace, and then these, really they're replacement rules, but they're giving me the values for x, for y, and for z that solve this. So I do get a unique solution for this collection of equations. So x is negative 19 over 22, y is 21 over 22, and z is 13 over 22. So notice it gave us the answers in this fraction form with integer numerator and denominator, which we may or may not want. Mathematica will always try to get the most exact form it can. So notice when I put in these coefficients and these values, it is just 2, there's no decimal point. Mathematica is going to treat 2 or 5 or 4 as an integer value. Whereas when there's a decimal point, it treats it differently as a float or a long or a different set. So actually 4 versus 4 point is a different number to Mathematica. When I run it now, just making that small change to 4 point and rerun it, now it gives me decimal values. It can't get that exact rational value like it got before. So I can change that back to just 4. Now sometimes we want a decimal, sometimes the fraction is better, sometimes a root or a radical is better than the decimal form, so it depends what we're looking for. There's also other ways we can force it to give us a decimal instead of the more exact answer. One way to force a numerical answer is instead of solve, we can use NSolve for numerical solve. And it actually uses a different routine to get our solution that will always return a numerical or a decimal value. So again, rerunning it. Now, even though this is still 4, everything's an integer here, it returned decimal values. So we can use NSolve if, again, we just want decimals. We can use that. Or finally, we can still use solve and then do a //n, and that's going to tell it, take our answers and put it into numerical or decimal form. And that'll do largely the same thing. But I'll keep them fractions for now because that's fine for this solution. So we've solved it. This is the XYZ that solves this linear system. But notice how it gives us the answer is another little idiosyncrasy with Mathematica. We have this double curly brace and then our answers. So really our answers are returned as a list of lists. In this case, though, the outer list is just has one element because there is one unique solution to this. But let's see a difference if instead of a linear system of equations, I give it a nonlinear system. So I'll put an x squared in there just so it's nonlinear. I'm going to have more than one solution. So again, this is just to demonstrate how it returns our answer and why it's giving it to us in this form. Now notice here there's 2 sets of solutions because I have this second order problem now. So I have the first XYZ that satisfies these 3 equations and the second XYZ. The numbers aren't important here. This is just to demonstrate that now I have in my outer list, I have 2 elements. I have this first set of XYZ and the second set of XYZ. Normally we'll be doing linear systems in this class. So what we can do to clean this up a little bit is at the end, we can put this bracket, bracket, 1, bracket, bracket, and you'll see me use this a lot because, again, most of what we do will be linear. If I run it with that, what that tells it to do is only return the first element in the list. So it got rid of that outer bracket system, so it's just a little bit less to look at. So this bracket, bracket, 1 bracket is kind of optional, but it makes it a little bit cleaner. But if you're having syntax errors, if it's not returning the right thing, you might want to make sure you don't use that at first to see what's going on because it might be trying to pull out like the first element of an empty list because you made a mistake somewhere else. And finally, using the solve, for any time you can highlight and push F1 in Mathematica, and it's going to open up the online help for that command and tell you how to use it. And give you some different examples of using it as well. So the Mathematica online help is really good, especially as you start working in Mathematica and learning some of the different syntax and some of the different functions that we're going to be using as we go through the course. So last thing for this example is we're sometimes going to make equations from various sources. So a nice thing about Mathematica is the way it stores variables. It can store all types of different information into variables. I'm going to make a variable up top here called x, or for equations. And what I can actually do is save a list of equations into a variable. Right, so I can save these and run this, and I've saved this list. Now in Mathematica, if I end with a semicolon, it's going to not show an output. So it's saving this list of equations into variable EQS. And now down here, I can just say solve variable EQS, which is a list of equations for x, y, z. And sometimes this is just a little bit more convenient to be writing it this way and then modifying the equations up top. Because I also might be getting equations from, let's say, free body diagrams and equations from other sources that I want to combine. Well, I can, in the solve command, put a different series of lists in there of equations and solve them all simultaneously. So in here, I'm saving this list of equations into EQS and then solving it in the solve command. And do note in Mathematica that it's going to run only the cells you highlight in anytime you run the software or run a cell. So for example, if I come up here and press the Shift Enter, it has now run only this cell. Then I can come down here and run this cell separately. So the problem is if I make let's say I change this to 5, but I don't rerun that cell, it has not re-updated what EQS is if I keep running down here. I need to run this first and then come down here to solve in order for it to rerun with the new values. So it does not necessarily run top to bottom, it runs the things you select from top to bottom. So what I can do is I can come over here and highlight multiple cells like this. Now we see that the first cell and the second cell are highlighted. Now when I push Shift Enter, it's going to run both of them in order. So it does not automatically update, it only updates when you run.